Your problem is here in the cabinet.
Right.
So you work your way back to the source of the power. Okay.
So wait, first you go to the breakers, and then you go back there?
Well, yeah, because now you go over here.
Right.
Now you determine the first thing that happen is the breaker's off.
Right.
Now your breaker's on.
Right.
Okay. So now let's just go back over here and check to see if there's voltage.
Okay.
Or if the breaker is on, you can open it up and make sure that the wires are connected to the breaker. Because sometimes some idiot might have forgot to connect it. They put a breaker in there, they left the wires coiled in, and you never connected it for whatever reason. They went on break and this
Came
person
back and
thought that the
forgot
other
it.
person did it and it never got done.
So first you go to the PPC. And
Yeah, first you go to PPC, you open it up, you check the breaker,
Right.
see if the breaker's on. If the breaker's on, well, unscrew it real quick just to make sure that the breaker's tied in.
Right.
If there's no wires inside that breaker, that's why you ain't got power.
And then you
Then you gotta strip the wire, put it in the breaker yourself.
And then you use the what is it called? The machine to test
A
the
voltmeter.
rectifier, the meter.
A voltmeter.
Voltmeter.
But like I said, you would if it's not tied in, then you have to tie it in.
Right.
Tying it in just requires stripping the black, stripping the red, putting the black and red in. It's gonna be a 2-pole breaker. You put it in. You put in your white. Everything's there. You just have to follow whatever's already there. Your black to your black and your red always go to the breaker because it's a 2-pole breaker. You know what I'm saying? You're gonna see neutral. You're gonna see a white wire. You see all the white wires connected to one same thing in the panel. You know what I'm saying? So you strip your white wire and plug it in the same spot, and the green wire, all the green wires are in the same bar. You just follow suit. It's really that simple. You know what I mean? It just gets a little bit more complicated when, if the wires don't fit because the wire's too big, then you call an electrician. Everything else is fucking pretty cake. Because if you sort of have to add and modify a panel, then you need an electrician to do that. Alright, so you go there, and if you check, like I said, you check that, everything's connected properly, then you go back over here. Then that's where you're going to have to open up the back, wherever the connections are at. What you're going to have to test is the block where you're plugging in your AC wires to. Now, if you have voltage at that block, then your job is done. Listen, I got voltage here.
You deal with it, yes.
This is your cabinet. You guys take it from here. All right, because this is all part of your infrastructure. Your infrastructure is your power and your fucking and your fiber or whatever communications you need. Because every cell site needs power and it needs telco for it to work.
So if we use the voltmeter at the rectifier,
wherever it connects to. Not necessarily at the rectifier, but you get it at where your entranceway is at.
Where's that?
It's usually in the back. You follow the pipe. It's usually in the back of the cabinet. In this particular project, if you're standing behind the cabinet, it's left side bottom.
Okay, so when we have power and we have...
Remember that conduit that I ran at 495?
Yeah.
That was for power.
Right, I know that. I understand that. I'm saying, so if we have if our voltmeter shows that it's working,
if you have 240 volts,
it's on them.
Yeah, it's on them. I don't know why your fucking cabinet don't work. You know what I mean? That's it. Our concern is to make sure that we cover our asses, what we build. Yeah.
Oh, so that was the PPC where you ran the cables.
Where I ran the cables to, that was the PPC.
All right. Cool.
You know what I'm saying? That was the PPC. Boom, I ran power.
Yeah.
Boom, I got power to that cabinet. Okay, so.
That's for an outdoor site, just to let them know. If you're in a shelter and you're dealing with different things.
Yeah, in a shelter you'd be dealing with DC.
Yeah.
Depending, though, not always. Because remember,
We're
clear
not
wire.
gonna be running into many shelters.
Dude, they got a shitload of shelters.
Oh,
now.
in the city?
In the city and in Bawa, all
Okay.
rooftops.
So then maybe we should kind
Yeah,
of
it depends. Well, like I said, for now, we're just going to go with this layout because this doesn't change no matter where the fuck you're at. You still need power, you still need
I don't
telco.
want them, if they were in there was a shelter, them like saying, where's the PPC?
Well, yeah, but it would be, it still have a panel though.
Yeah, distribution panels,
Yeah.
not a shelter.
Yeah, you always have a panel. Power's come from somewhere. You'll always have a panel, and you'll always have some form of rectifiers. Whether the rectifier is a power plant, like the GPS is on in the AT&T sites. Julie, GPS, 24 volt, where we install the shelves.
Oh, okay.
Galaxies,
The
indoor
galaxies.
Yeah, that's a giant rectifier.
Okay.
All the rectifiers are there, and it converts DC power. It all works the same no matter what. It may have different pieces of equipment. The only thing that changes is their equipment. That is all. Everything still works the same no matter what situation you're in. It always works the same. Your equipment is different. That is the only thing that's different is your equipment. And the nice thing is that
with the outdoor, you'll have like one feed, like your 100 amp,
yeah,
and then all the rectifiers are internal. Whereas
Right.
the indoor, you'll have a bunch of individual like 30 amp circuits.
correct. What you do is the easiest way to do it to determine what the fuck you got is follow cables. If you're in an indoor shelter, you don't know what the fuck's powering it. You look at it. What the fuck's coming in here? Well, coax lines don't carry power. You know what I'm saying? These little fucking lines, the red ones, the beige ones with like weird heads on them, that's not power. That means it's got to be these wires. Where do these wires go? Oh shit, they go into some weird fucking cabinet that has all the wires going into it. So I guess that's what's powering it up, this cabinet.
We're gonna schedule one song only.
Just really fast. Hello? Hey, what's up? Hey, let me call you back. I'm in the middle of something right now. Let me call you back. Yeah. I definitely will call you back. Trust me. I'll call you back like at 2 o'clock. All right, bye. Anyway. So you got that. You got your radio. You'll always have some way to determine where your power is coming from. You just go backwards from the cabinet, and you'll always be able to see where it's coming from. So, okay, now, that powers the radios. The radios by itself, they'll give you radio frequency. But if you don't put information on that radio frequency, the way everything works is that you can put packets of information that ride this wave. That's how it works. They put ones and zeros that'll, digital information. Digital is all ones and zeros. Digital information on these, and they attach it. They marry them, and they'll basically like a surfboard. Think about riding a surfboard. The information just rides the wave. So you have power, but you don't have any information. That's where your T1s come in at. Your T1s, it's like a giant, it gives you a funnel of information. That's where all your information is going to go to and come back to. Because like I said, if you're on a phone, you got your little cell phone here, and you send information over to the antenna. The antenna transmits it down to the radio equipment. It stops there. Because what the fuck's it going to do with it? Has to send it somewhere else. Has to send it to a switch. You know what I mean? So basically, the radio without the T1s are going to be useless. A T1 is a high-speed internet line. Okay? That's what a T1 is. It's a high-speed internet line.
You're saying that the digital information is riding the AC current?
Not the AC. Well, remember, it's a hertz. It's a sine wave. That's RF. Not AC. In this particular way, it's a hertz. It's not... That's AC, right?
Yeah.
But that's also a sine wave, the way it goes, the way current flows. RF, the current flows the same way.
Yeah, but if you're talking about how the telco is going from...
Well, no, it'll be on the RF. I'm sorry. I just used the sine wave as an example. But here. There. RF runs the same way. RF works the same way because you're dealing with a hertz.
So the T1s go to the radio, and then they take the zeros and ones, and then they ride the sine wave to the antenna.
Basically. That's what it does. So like I'm saying, so now if you're on a phone, you hit this antenna, you get the radio equipment there, it ain't gonna do shit. It stops because you need a T1. So now your T1, now what these radios do, it converts electrical energy into radio energy and vice versa. So it gets this radio signal, converts it to electrical energy and shoots it down to T1. Now this T1 could either be light or like copper. If it's copper,
One song only.
If it's copper,
Wait, can you just say the whole part again? Can you just say that over again? Like,
Okay.
you just said?
the radios will convert radio frequency into electrical energy. Okay? Now, depending on the layout and the configuration of the radios may also be able to accept, well, no, they never do. But anyway, so it's electrical energy, for the sake of saying electrical energy. Okay? So now electrical energy...
Radios convert RF into
electrical energy, yeah. You know what I mean? So now that electrical energy, you send it through copper down to T1. You know what I mean?
And
But
then,
now, okay, now here.
and then the electrical energy gets turned into, and
Router. So now, what happens sometimes is, now let's just say you always have a bunch of different radios, okay? Let me make this like this better, to be better understood. Okay, so now your T1 goes into your router, and so do your radios. Okay. What happens is that now your radios, all your radios go into like a type of router at the bottom. All right? So that this router sends a signal down to T1 and out. Now this T1 could be the copper or fiber, depending on what technology they're on. More likely not nowadays, it's going to be fiber. But if you're talking about the old systems, it'd be a copper T1.
Copper.
I always thought that in the telco cabinets, they always use Cat5 as a punch down.
Sometimes, yeah, sometimes. But the fiber is going into the CSC from the street. Because just so you guys can know, the difference between copper and fiber is almost unnoticeable in short distances. So if I have Cat5e from here to here, and I got fiber from here to there, you wouldn't be able to, if you're on a computer, you wouldn't be able to tell the difference. Not to the naked eye. It's almost the same. So using fiber from here to here is useless.
Roughly, where would you start to see?
Anything over 300 feet, because Cat5e, Cat5 is not good past 300 feet.
That's why you need that extender effect.
Right. But most of the time, that's when you want to use fiber. Anything runs on anything over 300 feet. Because technically speaking, it'll work. You won't. What it does have, when you're using fiber, it increases your bandwidth, so it increases your capacity. The more bandwidth you have, the more capacity you could put more information on. The smaller the bandwidth, the less capacity, less it can carry. So basically, the bandwidth would be the wave. You know what I mean? How big, how wide is the wave? The wave may be the same height, because that would be your band. That would be your reference point. That would be how high it's going, right? But the bandwidth would be how wide it can be. How many riders can ride that wave? That would be your bandwidth.
Fiber has an unknown bandwidth.
Unlimited usually, yeah.
Unlimited.
Yeah.
Because it was invented by the aliens.
There you go.
It's unlimited?
Yeah. Yes. The bandwidth is unlimited. Fine.
We're gonna schedule one song.
Hello? Hello? Yes.